Kotlin editor in your browser itself. So it's the easiest way to get started. So let me show you a simple program, a hello world program, that Kotlin program. So every Kotlin program starts with a main function. Like if I write this println hello world here, and if I try to run it, like expecting a top level declaration. So this is an important point. Like in similar languages like C or Java, you have to first write a main function, and that's the starting point of your program. So here also I will write a main function, fun main, and type in print hello world. And now I should run it. Here you can see the output is hello world. So we have successfully written our first Kotlin program here in the browser itself. One nice thing about this browser is that you can also copy this link and share with anyone. Like I've copied it. Now if I open a new tab and paste this link, then the same code will be shared to any other person also. So it's very easy to collaborate here, but it's just for testing out Kotlin. And if you want to get into more serious development, then you will have to download an IDE, that is IntelliJ's IDE. So IntelliJ IDE for Kotlin. Yeah, 1 second. So, and here's the link to download IntelliJ IDEA. Here, as you can see, there are 3 platforms, and select the platform. It will auto select based on your system, but you can manually select here also. Like I'm using Windows currently right now, so I'm selecting Windows, and there are 2 versions for it. One is the ultimate version, and second one is the community. So the difference between these 2 is the community version is free, and the ultimate version is paid. And these are some of the differences between both of these. But for a purpose, both of these satisfy that. So we can use either of these. One more thing about this is you can get ultimate ID using your college email ID. So you have to log in into JetBrains, and then you can download it and use it, the ultimate version, using your college email ID. So yeah. I will show you how to download and install this community version right now, so that everyone can do it. So it's just easy at clicking at download button, and it will automatically start downloading. So, and it will start downloading. So I already downloaded this program, so I will cancel it and show you what's after that. Here's the installer for it. Like most of the installers, it is also simple one. Just you have to click next. Okay, also next. Now you can create a desktop shortcut, add a path variable, and also select all of these file options, so that whenever you click on any of these files, it will automatically open it in this ID, and click next. Finally, you will have to click on install. Since I've already installed it, so I'm not going to do that. And once you click install, it will automatically install, and you can start it up using the desktop shortcut. Okay. So that was about how you can get this ID, and now I will show you how to write your program. 1 second. So now let's get started. As we have written our hello world program in the browser, I'm going to show that how we can write it in this IDE also. So like this println. You can also see that this IDE gives me autocomplete features like this, and tells me about what parameters I can pass into this function. So this is also a very handy feature, and you will use this a lot. You don't have to write complete println here. You can just write PL, and it will autocomplete. That's quick tip. So I will write hello world, and if I have to run it, I can simply click on this play button here. Run hello world. As you can see here, it is building, and here is my output, hello world. Okay. And another version of this println is using this print. So let me show you the difference between these two. So if I write hello, and beneath this I will write world here. This. Now if I will run this program, see what's the difference between these two print statements. So as you can see, this println prints into two lines, and print statement appends this into just a single line. So this is the basic difference. Like println inserts a new line after you have printed a single statement. So this was about the print statements. Now let us move on to variables. So variables in Kotlin are of two types. One is the mutable version, that is var, and the second one is val. The second one is val. So let me show you how we can use this. Let's create a variable called name, and I will give it a value pragmatic. This is a string type, and if I want to create a Boolean type, I can just write p equals to true. So true, and another one that is the false one. Okay. So now just to create an int, like float numbers, I can write 10. So these are the data types, and you can see that I have not written explicitly the data type of this. Kotlin automatically infers the data type from the variable. So if I try to write this, and this will show me remove explicit type specification. So Kotlin compiler is smart enough to know what is the data type, so we don't have to write it again and again. So this separates it from Java and introduces some simplicity and readability into a code. Now the second variable type is var. So if I write some number like age is equals to 18, and then I can reassign it age is equals to 20, and it will work just fine. But if I now try to do price is equals to 15, no, it will give me an error. So the main point is here that val is immutable. That means that you cannot reassign it once you have made it. It's only a read-only property. So now if I try to print all of these, name. In ID, in the IntelliJ ID, you can press Control D to copy the statement multiple times. So I'm going to copy it 4 times. Happy and each. What will the output? So you can see Prakhar true 10.55, and the main point is 20. So the age value got reassigned to 20. Let's now take a look at taking user input. Taking user input is very simple here. We can just write enter your So to take the input, we will just write read ln. So it will whatever we input here, it will take that input and store it into the name variable. Now I can output it to show you. Hello. And one more nice feature in Kotlin is you can use string templates. So what are string templates actually? They embed the value of your variable directly into your string. So we write a string template using a dollar sign and then the name of the variable. Now it will output, let me run it and then we can see. So enter your name. So I will write Prakhar and it outputs hello Prakhar. We took the input from readln, store into name, and then the name value of the name variable got inserted directly into the string. So as you can see, it's much more readable here. Instead of writing hello plus name here, that previous syntax was more readable. So here you can see the benefit of Kotlin over Java and similar languages. Okay. So functions. Basically, what are functions? So functions are reusable pieces of code. We don't have to write every time I want to like do some calculation. Like if I want to multiply two numbers, then I would have to. I can just create a function and then I will just call that function in single line and it will get executed every time. I won't have to repeat myself. So that's the basic uses of function. Now we can write we have been writing a main function from the start. Now I will write a custom function. The main function is mandatory in every program. Now a custom function can be written using the fun keyword. So fun with Kotlin comes from here. So fun, like we can write a function to multiply two numbers. So multiply, and then it will take two inputs. First one will be an integer, and the second one also int. And then we have to specify what will be its return type. So return type will also be an int when we multiply two integers. The upper is also integer. So here, and then I can just write return x into a into b. Now this function is complete, and I can call it from here. Let me take the input from the user for these two integers. So well, a is equals to read readln dot toInt. I will have to cast it into an integer because the readln takes input as a string. So I will cast it using toInt. Okay. So now I will take the another integer. 2 equals to readln dot toInt. I will use result. I will now call this function. Just bring this and this. So let me write the first number as 5 and the second one is 2. So what is 5 multiplied by 2? It's 10. As you can see, it is working properly. Now, in Kotlin, you can simplify this function definition more. The function contains just a single return statement. Then what you can do is you can return this return statement, then remove these curly brackets, and remove this return type, and just write equals like this. So you can see how in just a single line I have defined a function, and it looks much cleaner. It will work just fine. I can show it to you. So 5 and 2, and answer is 10. So this feature makes our code much shorter and neat. So this was about functions. Now let's see if statements. If in Kotlin, if is also statement and expression. So we call it if clause. You will see later why I'm saying so. So let me write a program to demonstrate this. So I will take input. Let's take age. And if the age is greater than equals to 18, then I will print adult. Else. Okay. Now I will run this program. So this is how you write the if statement in Kotlin. So I run it. So if I enter 20, so what will be this? What will be the output of this program? Can some adult? Yes. Yes. Aditya. Okay. Okay. Yeah. Correct. I will run it. So answer is adult. No, actually we can remove these braces also. These are not necessary. We can convert it into a single line also. If println else. So this is also cleaner look. And now I'll show you how we can use this if statement and as an expression. So what I that we can output some value out of it and store it into a variable. Let me output it from here, and I will store it into a variable and call it out. So you can see that I'm using an if clause, and the output of that is stored into the out variable. Now, if I just print it here, L out. Is 20 sync. The result is adult again. In other languages, we have to write some ternary statements, like in C or Java. We would have to use this. Age is greater than 18, then adult or kid. In Java, you would have to write it like this. So which one do you think is more readable, the second version or this first version? No, yes, we can remove this also. Yeah. The first one, yeah, yes, correct. Yeah. So yes, so this also demonstrate that how expressive the Kotlin is. So let's do some looping over here. Okay. So see, if I want to write it from the beginning. Now, if I say I want to print hello 5 times then how would you write the program? You would use a for loop and use the int variable 0 and till 5 you will run it, and you will write like cout hello, or in Java system.out.println hello. But now see how we can do it in Kotlin. So I will just write repeat. How many times do I want to repeat it? 5 times. Now what do I want to do? I want to print. I want to println and hello. Now, if I will run it. See, here it printed hello 5 times. And how much readable it is. Repeat 5 times. What do you have to print? Print hello. So this is much more readable, I guess. Now I will show you more variations of this for loop. We can also write for int I in 1 to 5, and I can. So what do you think will be the output of this? Here I'm saying for I in 1 to 5, print I. Can someone tell me what will be the output here? Yeah, correct. There will be a new line, but you are right. Now let's run it. 1 second, I should comment out. Yes. say 1, 2, 3, 4, 5. So what do we get from there? Like 1 and 5 both are inclusive. Okay. Now, what if I want to increment this I with some other value? It's currently incrementing by 1. So what if I write I in to 5 step 2 I. So I will run it and see what will be the output. 1, 3, and 5 Aditya again correct. Yeah. Nehal, you are also correct. Yes, yes. Now, another version for loop for I in 1 until. Now let me see who will get this correct. So what will be the output of this code? Okay. Yeah, correct. So this 5 here is exclusive. So if I will run it. So 1, 2, 3, 4. That's the correct answer. What if I want a string and print its character? How can I do it? I can just write for int I in ACD. Let's print the characters here. Print I. So I looped over the string and printed out all the characters here. Yeah. So this was about the looping in Kotlin. Okay. So let's go to arguments. So Vararg is short for variable arguments. So consider situation here you want to create a sum function for 2 variables. You are given a task that you want to create a function that would sum up 2 variables. Now, how would you do it? That's easy peasy. So you will write sum function x of type int, y of type int. Now, what will be the return x plus y? So, and yeah, that's right. Now I can just print it sum 1, 2. So this will just work fine as we have seen in an earlier example. Now, what if I wanted to sum up 3 variables? What would you do? And you still want to sum up for 2 variables, but you also for 3. So you will just copy this function and create another variable here and sum up these 3. You will write this. Now, what if I say I want one more function for 4 variables? What would you do? You will just repeat this and create an amount of variables here. So I will go back to A. So A in this plus A. So here's a lot of repetition. And what is the principles in the principles of coding? We should keep a code dry. That's don't repeat yourself. So here we can see a lot of repetition is there. So how can Kotlin help us here? So what we can do is we can take the help of Varargs. So I'll write Varargs numbers of type of int, and then I will just return numbers.sum. So now it will take any number of variables. Like if I am 3, 4, 5 here and run it. So yeah, here's a sum 15. 1 plus, yeah, you can figure it out. So that's correct, 15. Now that's for 5 numbers. Now if I run for 3, let's check if it works or not. It's 6. That's correct. We have just written a single function and it is doing the work of like hundreds of functions. So, and it is also readable. As you can see, we are just writing varargs instead of JavaScript. That we have to create three dots, and that's not already obvious that what the three dots are doing. We can just write varargs, and it will do the work for us, and it will also be readable. Now you're just working with single variables that were storing a single value. Now let's come on to collections. How we can store multiple values in just a single variable. Yeah. So how to create a list? What would you do? What would you write? Like one list is just a list of what? What do you want to create a list of? Just 1, 2, and 3. And here it is. You have created a simple list in Kotlin. And what if I wanted to use some floating point numbers here? Stuff 1.1, 2.2, 3.3. So I've created a list of doubles here. And not only we can use the same type, but also different types. Like I'm creating mixed list here. There will be a mix of like an integer, a string, floating point number. Let's take another list and make it inside of it. List of 1, 2, 3. So yeah, you can see there's no red line or any issue. This is just fine. Now, and the return type and the data type of would be this any. So any in Kotlin stands for object. So, I can store any type of variable inside of it, and I don't have to specify it because the Kotlin is smart enough to figure out what's the type of this data type. Now let's access some properties of this list. So how can I access? I can just use this square bracket notation. You should be familiar for it. And I'm accessing the list also zero base indexing follows. So now what will be the output of this? 1, 1. Yeah, that was pretty easy. So let me run it. Let's output 1. Okay. Now, what if I wanted to print the whole list? What would I do? In other languages, I would have to write a for loop and then print out each element of it. But in Kotlin, what I can do is just write println, and what I want to print, I want to print doubles. So it printed the list easily. I can use the for loop here also if you don't want to follow this. So it will print out all of these 1, bracket 2, and list of here. As you can see, this output is correct. Now I'd like to show you something. What if I wanted to add something into this list? What can I do? I can call add. In other language, we can do list.add and something like 4. But you can see this is giving me some error. Like there's no function add inside of this list because every data structure is by default immutable in Kotlin. So you cannot append anything or remove from it. It's immutable. So you will have to create a mutable data type. You create a new list, mutable list of 1, 2, and 3. So what the difference it is, I have written here mutable list of here. Now new list dot add. You can see there's no error 4. I can easily add anything and also remove from it. New list dot remove 3. Okay, so we print it. You can see 1, 2, and 4. It added 4 and removed 3. It is working just fine. Now this can also look some clumsy here. So what can I do? I can just write new list. I want to add 10 to it. So just like this. So it will append 10 into this list. We won't have to use add or remove here. Now, if I want to remove something from here, I can use the similar syntax, minus equals to 1. And I'll open this list. Let me move it. So 2, 3, and 10. So it removed 1, 2, 3, and added 10 here using this switch syntax here. Okay, so I will show you how we can add two lists. Just a list of, now I'm creating two different lists. 1, 2, 3, and another one. So I list 2 is equals to list of 3, So now if you wanted to do a similar thing, like you wanted to append all of these into a single list in Java, suppose, or in any other language, what you would have to do? You would have to create a new list and then iterate over this whole list one using a for loop and append it to the resultant. And similarly for list 2, you would have to append it into the result. But in Kotlin, it's so easy. Like you can just write list 1 plus list 2. And it will take care of everything. See, so this was the earlier output. So 1, 2, 3, and 3, 4, 5. So it just appended both of these. Now, what? Now I'm giving a challenge. Now, guess the output of this. What would happen if I subtract these two lists? What will be its output? Can this happen? And if this can, what will be its output? Yeah, error 1, 2, 1, 2, 4, 5. Okay, so let's give it a try. 1, 2, yeah, okay. So here's the output 1, 2. Some of you got it. That's correct. So it will just remove the elements which are in which were in list 2, and when it will output here. Okay. So this was all about lists. Now we will use C maps. How we can use maps in here. Now similar to how we created list there, we can use map is equal to map of. Now what do I want to create a map of? I want to map 1 to 1 and 2 to 3 to 3. So how would you, like in English also, what would you say that I want to map 1 to 1, 2 to 2, and 3 to 3. So it's very close to English, and that's why it is more readable. Now if I print this map, let's see what will it print. One map. Yeah. So it printed 1 equals to 1, 2 equals to 2, 3 equals to 3. So it created a mapping and printed out easily using this single line. How can we access its properties? So I can just write using the square bracket notation also, or I can use get here. But the square bracket notation is much more concise, so I'll use this. So map of 1. Yeah. What now? Let me run it. So as you can see, it printed 1. So what was 1 mapped to? It was mapped to this string 1. Okay. So another challenge. Now, what if I write print ln map of 4? 4 is not present in this map. So what will be its output, if somebody can guess? I see error, empty string. Okay, yeah. Okay, so let's run it and see. So it outputted null. Actually, it does not exist, so it outputs null by default. Now, it was a map that was mutable. So if we are not specifying that if a collection of, if a variable is mutable, then it won't assume that also. Now, if I want to create a mutable map, like a list, I can add new map, is equals to mutable map of, and I want to create a mutable map of what? An integer to string mapping. New map of 4 is equals to 4. Earlier, it would have failed, right? Map of 4 equals to 4. So it's giving me an error that actually we don't have this property, that we cannot assign anything. We can just read the data out of it. But here, new map of 4 equals 4, it's completely valid because this one's immutable and this one's, as you can see, it's mutable map. Okay, so I'll create one more map of 5. And as in list, I can use the minus operator here to remove some properties. Minus equals to 4. So it will remove this 4 from map. And so let's see what will be the result. New map. So yeah, so as you can see, it removed 4 and it just has 5 here. Good. So this was all from my side. Now Arpit Bhaiya will take over from here.
Great. Let me share my screen first. So we have seen a lot of basic stuff with Kotlin. Let's see how we can use all those to create new programs. Let's start with this one. So we need to print the following pattern. Like everyone knows how to print this, right? Everyone has done it once probably in school time. But let's see how can we do this in Kotlin. So let's first define a variable which denotes the number of rows we have. Let's say we have 5 rows. Now, what should be the logic for this? So we have, okay, let's take 4. We have 4 in the diagram. So we have 4 rows and we need a loop which goes 4 times. Like, so if you guys can think of, you can already write it in your own language. And what you will do is you will create a loop which runs for 4 times or n times. And then inside that loop, you will have a nested loop that prints the spaces. And then again, another loop which will print the stars. Now you could print the stars in one loop or in like 2 loops, depending upon your logic. Let's see how can we write this in Kotlin. So the first thing is we need a loop, right? So let's use the for loop for I in 1.n. What is this? We have a range here, 1.n, and say that we have to move from 1 to n, and the variable is I. Now, when we have this I, we need to get some logic to count the number of spaces that we have. So, like forgot this part, the left-hand side part, and we'll only print it here. So this part will print towards the right of this. Now, for the first row, we have like 4 spaces. Like for this case, we have 3, like 1, 2, 3. For second, we have 2. Then we have 1, and then we have 0. How many spaces we have for ith row? Simple, right? N minus I. So for 1, we have n minus 1. For n, we have 0. So we have n minus I spaces. And can someone tell me how many stars do I have for ith row? Can someone give me the explanation for that? For I is equals to 1, we have 1. For I is equals to 2, we have 3. Then 5, then 7. 2i minus 1. Yes, correct. So for first we have 1, then we have 3, 5. So we are increasing by 2 at a time. And then we have like 2 times I minus 1 spaces. Star, sorry. How do we write? We write print. So we need to print and change the line. We need spaces. How many spaces? We need n minus 1 spaces. So we need to repeat this string n minus 1, n minus I times. So in Kotlin, we have a function called repeat. See, we have repeat. We can put n minus I here. So what it will do is it will repeat this n minus I times, or you can say it will create the same string. Now we have printed the spaces, and now it's time for stars. So that is star. How many times do we have to repeat it? We have to repeat it 2i minus 1 times. So 2i minus 1. That's it. Let's run it. So it will take some time to build. I should have built it earlier as well. Come on, do it. Yes. That's the pattern. Let's change n. Let's make it 6. Run it again. And now you'll have 6 levels of these stars. So like that's pretty simple. Like just one line of code to print the entire logic. Now, like how many of you are familiar with Python? Like has anyone used Python? Yes, yes. So can someone give me the corresponding line for Python? Like how do we write this code in Python? There's actually a better way. Can someone give me the statement for printing like n minus 1 stars, n minus 1 spaces, and 2i minus 1 stars? Does someone remember it? Type it out. Yeah, something like in Python, what we can do is we can multiply strings with integers, right? So any string times, let's say arpit times 4 will be arpit repeated 4 times. This is one powerful feature of Kotlin, like Python. So if you want to write this in Python, it will be something like this: print and then space and multiplied by n minus 1 I. And similarly, we can multiply this star by 2 times I minus 1. Now, if you try to do this in Kotlin, that's an error, right? So Kotlin says I cannot do this. I cannot multiply string with an integer. So it looks like we cannot do it here, or can we? We'll come back to it later, and we'll see Kotlin as well. Like, can we achieve Python kind of syntax? Not really Python, but something better than that. And we'll come back to this problem at the end of the session, like after covering the last topic that we have. So let's leave it here at repeat only. And we'll come back to it. So next, let's take another simple example. You want to check if a number is prime or not, right? How you can do this? And how would you do this? So a similar code in Python would be something like you will start with a variable, you will set it to true. So you are assuming that the number is prime. Then you go for a loop. You start from 2 and you go until n, right? So you go from 2 to n minus 1. And what do? You check if I divides n prime. So you set this variable to false. And you break out of the loop. And then you can print if it is prime, print prime, else, and not prime, right? pretty straightforward. So this is the function we have, and this is where we are calling it for 11, 14, 17, 27. Let's run it. And before running, can someone give me the output? Like what will be the output? There are some primes and non-primes, not primes. Prime, not prime, prime, not prime. Let's see. Yes, so pretty simple. But this is a lot of work to do. Like we only wanted, what we actually wanted to check was, this number is prime only if none of the numbers in this range satisfy this condition. That's it. That's what we wanted to check. But we have to create this new variable and this loop and break statement just to implement that logic. Now, what's the Kotlin alternative of that? Now you can see that you can write this kind of code in Kotlin, but it's not the most ideal one. We can do much better. Let's start with this range, 2 until n. And what we want is that none of the numbers in this range should satisfy that condition. And we want to check for none. So we write none. And we have a function called none. What this none function takes is, it takes a lambda, which returns a Boolean. So we can put our condition here. And now one more thing. Like when we were writing the loop, we were using the variable. Inside this lambda, we can use this it here. You can see the hint here that it is an integer and it refers to elements in this collection. So now our condition will be something like n mod it is equals to 0. So the number is prime if none of the elements in this collection, in this range, satisfy this condition. That's it. And also you can see the ID is telling you that we do not need var here. So because we are never like changing the value of this variable. Let's run this one. And same output. But also let's do one thing. Let's not print it here, because right now it's kind of an impure function. Let's make it a pure function which does not have any side effects. So let's return true or false here. So for returning, let's first rename it to this prime. That's a better name. And what we can do is, instead of printing it here, we can return it. So return is prime. We are returning it, we need to change the return type. So we can make it a Boolean. When we are returning it, we don't even need this variable. You can see this ID suggestion here, this green line. It says inline variable. So let's inline it. We don't need that variable. It was just to store and return it. We don't need that. And now we have this Boolean output here. Let's print it, right? So we can print this all. Let's print all of these. So one more thing we can do here is an important feature. A lot of times we happen to have functions which are just returning something. Like earlier you had seen this function, right? Sum. So it took two variables, and what it did was just return their sum, right? So we have a lot of cases where we have functions which are doing nothing but just returning stuff. Why we have error here? Okay, conflicting. Okay, we have declared this function in other file as well. Let's name it sum2. A lot of time it happens that we have a function which just returns something. Kotlin, what we can do is we can replace it with this kind of syntax, and is equal to 1. We have this function which returns this value, and the return type is automatically inferred by the compiler. If you want, you can specify it. Otherwise, it will be inferred by the compiler. Let's run it one last time. And we are expecting a true, false, true, false. Let's see if we get that. True, false, true, false. Yes. This is our final code for is prime. Just a one-liner function to get the prime number, to check if a number is prime or not. So a lot of times it will happen that you will write code that you can write in that way, in imperative style, But you can almost always refactor it to something like this, which is a more functional style. And it looks much more concise and readable. Like we are just checking if 2 until n has none of the numbers that satisfy this condition, the number is prime. That's it. So another example of Kotlin's conciseness. Okay, if anyone wants to ask something, they can, or we'll move to the next topic. Okay, let's see what we have next. So a lot of, like most of the times in real use cases, we are not always working with ints and strings and booleans. We want some complex types, for representing complex entities. So how, like normally we do it using classes, right? So we have classes in Java, we have classes in C++ and Python as well. In C++ we have structs mainly. So, and classes as well. So we have classes in here as well, and to represent complex stuff, but the classes in Kotlin are way more simple. For example, let's create a class called person. Right? We have a class called person, and this person has a first name and a last name. So how do we define those? You open parentheses and you create those two properties. Like you have first name, it's a string, and you have a last name, which is again a string. And guess what? That's it. Like if you want to do this in Java, you have to create a lot of like constructor, getter, setter, and all that. But in Kotlin, you don't have to do this. It's just a one-liner function, just a person class with two fields. Now, how can I create an instance of this class? How can I create an object of this class? Because we have this class, now we want to use it. So let's create an object. Let's name it person. And just name this function. Inside it, just pass the two arguments. So in my case, let's pass just Arpit Shukla. We have the two arguments here, and we don't even need a new keyword. So if you remember from Java, we had this new keyword. In Kotlin, we don't have that. Let's create another person, for example. Let's call Peter. Now, let's say Peter does not have a last name. So in case a person does not have a last name, what we can do is we can give it a default value. So if someone does not specify a last name or any property, ask Kotlin to just use this particular default value. And these default values come very handy when working with like complex data types. There are a lot of times where you want to give defaults to either functions or classes and this stuff. We have this new person, which is Peter. Let's try to print some properties out of these. Let's print name. So like it's very obvious, like from person, you can get the first name by calling person out first name. For person 2, you can get the first name. Let's print it once. And see what's the output. So Arpit and Peter. But there's one thing, like if you try to print the entire person, it will give kind of a garbage value. Because what it does by default is it gives the reference of that object that we have here. So this kind of a garbage value, it's not exactly garbage, it's the reference. But we don't want that. But this is what we get by default. Like in any other language like Java, C++, Kotlin, and no, not Kotlin, Python. You try to print the classes, you'll get such kind of stuff. Right? We don't get a proper output. In Kotlin, we have another syntax, another variety of these classes, which is a data class. Just add this keyword, this data here. And this will give a lot of different powers to this class. Let's try to print it now. Now it's case like the output is much more readable and makes a lot more sense than before. We have a person with the first name Arpit, last name Shukla. So what data does is it gives a lot of multiple default implementations for functions like toString, especially toString. Like how can you convert this class to, and there are other stuff as well that you can do. For example, what you can do is if you want this class person, but you only want these first and last names. So instead of storing it in a person variable, then accessing it like first name and last name, you can kind of destructure it. So first name and the last name. Now you can just directly use those first name and last name variables. That's again thing that data classes provide us, that we can destructure these classes into their individual types. So if we do not need the person object as such, we only are interested in the first name and last name, we can just destructure this whole class into two variables called first name and last name. Okay. So that's about data classes. Now data classes are pretty common. You need a combination of types. Usually create a data class. We do not rely on like pair or pair of pair or something like that. Like even with two types, it's better to use data classes. Okay, now we have seen about lists. Let's see some operations on lists. What all can we do with lists? And how easy it is to work with lists. So let's start with the simple thing. We have already seen how to print a list. So here I have just a simple list of integers, right? So -1, 2, -3, 4, 1, -2, 5. So simple list of integers, and what we can do with it. So print list. We all can guess the output like we have seen before. It will just print the elements of this list. So we have the list printed here. Now let's do some more stuff. Now we need to print a list whose each element is found by squaring the corresponding element of this list. So in this case, we want like 1, 4, 9, 16, 1, 4, 25 like this. Now, how would you have done this in C++ or Java-like language? What you would have done is you would have created a new list of the same type integer, a mutable one. Then you would have to iterate on the original list, and then for each element I in the original list, you would have to insert I times I in the new list. Like 3 lines of code around. What does Kotlin offer? So we want to map this list in a different list. So if you want to map it, we call .map, right? And in this map, we can just access the variable by it, as we have done before in prime example, and just write it cross it. That's it. You want to map a list to another list where each element is squared. Just map it like this. Let's run it once. And we have the list of squares. Another use case. You want to filter a list. Like mapping and filtering are very common operations on lists. So if you want to filter a list, we want to like filter all the positive numbers from this list. How can we filter items from a list? You have list. If you want to filter it, we call filter. Whatever you want, just name it, and most of the probably it will come by default, because Kotlin standard library provides implementations for all these functions. Now, what is the condition by which we want to filter element? So we have this element called by it, and we want to put a condition here. So the condition is it should be greater than 0 for it to be positive. And let's run it now. We have all the positive and filter out. Now, one powerful feature of Kotlin is that you can chain these functions. For example, like if you want to filter a list and then map into a different list, we can do that as well. For example, let's filter it like this, and then we can map it, let's say the cubes, not even cubes, let's say times 3. Can I even predict the output? Like what will be the output? Give it a try. So we have 3, 12, 27, 3, 12. Okay, anyone else wants to try? Okay, we have another response here. Great. Okay, let's see. Let's run it and see what's the output. You have 3, 12, 27, 3, 12. Right. Some of you have guessed it. Pretty cool. Does anyone know this? Like, what would have been the Python version? Because Python is said to be like the most concise language. So how can you filter and map in Python? Give it a try. Using lambda function. Yes, you have a filter lambda function. You can do that. But the syntax will be pretty big, right? Okay, let me try one way you could have done. So I hope I remember the Python correctly. So you'll start with a list and then something like I times 3. And then you would have been like for in list. And now in this list, if you are about to use like filter, you would have to, I'm not sure if this is the right way. I hope you do it like this. So you have filter, then you have lambda, then you say X, something like that. I don't remember. Like one way I remember something like this. If not, this should also work if I remember it right. But the problem with this kind of syntax is you need to jump here and there. So when I read such kind of code, the way I interpret is this. I start from this thing, from the mid for I in list. So I'm iterating on the list. And then I'm filtering the numbers which are less than 3. And then I jump to the start. Now what I'm doing with those filter elements. So I'm doing like I times 3. So like, the only problem that I find with this code is that I have to jump it here. And this one seems much more readable and understandable to me. Hopefully to you guys as well. So we first filter, we then map, and then if you want to apply some more operations on that, you can just keep on changing those operations and it will work. Let's take another example. We want to print the sorted list. So we have a list and we want to get the sorted version of this list. What function do we call? Sorted. Now it might have become kind of obvious to you guys, like what are we doing? We have a requirement, we just first call the function and most of the times we will get it. Okay, let's see the sorted response here. So yeah, the list is sorted like -3, -2, -1, 1, 2, 4, 5. Simple. Like much better list dot begin comma list dot end. Okay, by the way, what if we want to sort it by descending order? Call sort descending, right? Just name it and you get it. We have a slightly different requirement. We want the list to be sorted, but I don't want to use these real values. Okay, let me just delete this code first. So that we have more space here. What we want is that these elements should be sorted not by their real values, but by their absolute values, right? So -1 and 1 should be treated as equals, -2 and 2 should be treated as equals. Now in language like C++, you would have to pass a custom comparator to it, like list.begin, comma list.end, and then a weird syntax for the lambda function. What we have here. So we want to print it. What do you want to print? Like instead of printing, you can just store it in a new list as well. That will just work. You can call it sorted list. And I've started the list. And I want the sorted version of this list where the elements are sorted by. There is function called sorted by. And here we can pass the value from which we want the comparison to be made. So in this case, we want it to be done by the absolute value. So It's that simple. Like I want this list sorted by their absolute values. You just write list dot sorted by absolute value of it. Can someone guess the output? What will be the output? No, we are not actually changing the original list. So it won't be 1122. We are not changing it. We are just saying that sort this list, but for sorting, use this, not mutate the original list. So we have a response -1, 1, 2, -2, -3, 4, 5. Let's see. And what you guys guessed earlier was like you changed all these negatives to positive. That doesn't happen, right? So we do not. What happened? Okay, we didn't print it. We'll take a look at a better use case than these integers in the next part, like just next. But let's finish this first. We have -1, 1, 2, -2, and as Lakshman mentioned, it is stable sorting. So what does it mean by stable sorting? Like if -1 occurred before 1, so in the final output also -1 will come before 1, and here like 2 came before -2. So in final output also 2 will come before -2. So for will preserve their original order. So the sorting is stable indeed. Okay, get a subset of lists. New requirements. Now we have a list of, let's say, long list, and we want a part of it. For example, we have this list and we want to take the first 4 elements of this list, right? So how do we do that? Dot take 4. You can't get anything better, I guess. You want to take 4 elements, right? Take 4. If we map or filter a mutable list, do we get back mutable list? Actually, no. Okay, let's try that one also. What happens with mutable lists? So we have a mutable list here. So let's copy the same elements. Kotlin doesn't like mutability a lot. It offers you, but it doesn't like much. So another thing we have this mutable list is we have this sort function, right? We do not have this sort function with this list. If you try to sort this list, it won't work. It is not available. And the reason is that we cannot change the content of this list. It's immutable. But for mutable lists, we get this function called sort. So we can sort this original list itself. So we don't need to even create a new list. We can sort it in place. Not in place, but like we can sort this original list as well. Now, if you want to get sorted, a sorted version, it will return a list of int, not a mutable list. So it is a list, and you can convert any list into a mutable list just by calling to mutable list. And if you have a mutable list, you want to convert it to list, you call to list. Kotlin also offers like sets as well. So if you want to convert it to set, you write to set. You want to convert it to mutable set, you call mutable set. You have sorted set. Name it and it will appear. We were at this. So we wanted the first 4 elements. So we just took the first 4 elements and we have them here. Now similar to take, what if we want to take the last 4 elements? So if you want to take last 4 elements, we write take last. Right. So what should we get here? 4, 1, -2, 5. Four, 1, -2, 5. Okay. What if we want to get everything except the first 3 elements? So what we want is to drop the first 3 elements and get everything else. So we want just call drop. I'm not even running it, like you can assume that it will work. So it will give the 1, -2, 5. What if I want to drop the last 4 elements? Write drop last. It will drop the last 4 elements and give you this back first 3. Okay, let's try this. We have take 6 or drop 2. What will the output of this? The slicing work here. We'll see. Okay. You want to see slicing? Try to guess the output of this thing. Take 6, drop 2. -3, 4, 1, -2. Yes, so it will be -4 like this one. It won't be it won't start from here, because when we say drop, we are dropping the first 2 elements. Like we are taking the first 6 ones. So this will return this list, and then we'll drop 2 elements. It will drop the first 2 elements, and we'll get these. Let's run it. Drops from start. If you want to drop from last, we have this function called drop last. You would have seen, like this is the drop last function. Drop and take by default work from the front side, and for the last one you need to specify last. Okay, let's talk about slicing. So this looks a lot like Python slicing, right? You have in Python you can write something like this. So an index A to index B. So we don't work a lot with symbols in Kotlin. We usually use functions. So if you want to, let's see whether do we have slice. So we have slice, right? Just name it will come. And let's see, we want elements from 2 to 4. How do we write it? 2 to 4. Like even the ID tells you like this less than or equal to sign. So these ranges are inclusive. Also, these are the indices, right? So from we will start from here. What is 2, 3, 4? So these are the indices. So 2, 3, 4, and inclusive. So you can slice. Just call the function called slice. Also, I have not typed these letters, so if you can see, like I only typed this one. So it's just the ID giving me hints. So I typed slice 2.4. You can slice it as well. And all these operations work with strings as well, right? So I'm not giving those examples, but for strings, if you want the first 4 characters, you want to get the last part of a string, that will work in a similar way. One last example for this page, which is we want to count something, right? So we have a list and we want to count the number of elements that satisfy a particular condition. Let's print one. Guess what will the function if you want to count something? Can someone guess? You want to count something, what function should we call? Dot count, yes. Pure English. So now we want to provide the condition, that what's the condition for which we want to filter out the elements. So let's say we want elements. Okay, we have to count negatives, right? So let's say what the comment says. So 8 less than 0. How many elements do we have which are less than 0? So we have 1, 2. The output should be 3. We don't use I. Okay. Another thing that we by default get this variable called it, right? So inside a lambda by default we get it. But if you want to rename it, you can also do that. For example, I want to call it I and not this. So just write I and put an arrow here. And now you can use I. So if you want to rename it to something different, you can do that. I want to call it number. You can call it number. By default, it's it, and you can use it. If you want something else, you can rename it. And remember this count example. Like in a letter section as well, I will reuse this count example to demonstrate something else, like another cool feature of Kotlin. So what this count function does is we give it a lambda, we give it a condition, and we just count how many elements satisfy that condition. Okay, so we have worked with list of integers, right? So let's take a pause and let's shift gears. Now we don't always have integers, right? So we have more complex types here in real life. So let's see some of these same functions with complex types. What do I mean by complex? data classes. And data classes are not complex, by the way. They just do complex stuff, but they are not complex. Next slide. Okay. So here we have a class called form response, right? So I hope a lot of you had filled this response. I'm not sure if it was filled for first years. College asked us to fill a form. We are telling where we do we want to come back to campus and our details and were we COVID positive, right? So let's try to simulate something. We have a data class called form response. It has 3 fields like name, branch, COVID positive. It's a Boolean. So we are working with this data class right now. And like I have already prepared some data. So we have a list of students. Let's call it responses. Now this is a list of, again, 4 form responses. So like earlier we had created a list of integers. Now we are working with list of form responses. And how do we create a form response? Just open this parenthesis and pass the variables, the values. So for name, we have these 4 names: Alex, Bob, Charlie, Cherry. And for branch, we have triple E, CSC, CSC, triple E. And quit positive, true, false, false, true. So this is the dummy data to start with. So the first thing we do is we want to print it. Now printing it wasn't trivial. We don't have list here. This trivial because here we have a list and usually we had to iterate to print a list, and also for classes we had to like print each like type one by one, each property one by one. Can Kotlin do it all by itself? Let's see. I run the wrong program. So you can see the output, right? Responses, and it has printed everything. So it's an array of form responses, and we have all the responses here. So Alex, Bob, Charlie, and Cherry. So Kotlin can indeed print everything. However deep it is nested, and it's pretty useful for debugging purposes. So for example, we are working with some data and doing some operations on lists or something, and then we want to check what's the current state of the list. What work have I done? Just print it and it will get printed. No need to iterate over it and all. Now we have a list of these responses, and now what we want is we want to get the names of all those people who had submitted a response. In other words, we want to map this list of responses into a list of student names. Can someone give it a try? Like what will be the code? We want to map this list into a list of student names. How to get every response in different lines? So for that, you will have to like literally iterate over it. So, but there's again a better way. For I in responses and print response. Print I. Responses.name won't actually work. It's not that concise because response is actually a list and you are calling list.name. So that doesn't make sense. Response is just a variable. Kotlin doesn't know what responses is. So for Kotlin, responses is just a list, and calling list.name won't work. So here you can get like all the responses in different lines. And actually, we don't actually use for loop. We have something better. So responses.for each. So it's a more functional style. So it does the same thing that a for does. So it gives you this response in this variable called it. You can rename it if you want using that arrow syntax. But again, it will again print the same thing. And again, there's another thing that you can do actually. You can write it like this. So if you want to print the responses, one in each line, just converts that println function into a function reference. We won't be covering this part here, but just to show you that it also works. So we have this responses for each, and we printed each response in a new line. Okay, we wanted to map it to a new list, right? So println, we have responses. We want to map it, we call .map. And as you can see, it here represents a form response. So we want to convert it into it.name. So we want that list of responses to be converted to a list of names. And like the return type of this will be a list of string. If like save it in a variable responses.map, we can see the return type is list of string, but like Kotlin can automatically infer it by itself. Let's run it. And we have all the names here, like pretty straightforward. And in other programming languages like C++, Java, you'd have to create on this list and then create a new list of strings and then just put it i.name or student.name or response.name in the list. Another use case, check if none is COVID positive. So we have been given a list of responses and the administration wants to check if any of the students is COVID positive or not. And if any one of them is positive, they will not call us back. Weird condition, right? So we have these responses and we want to check if none of them satisfy the condition of being COVID positive. So we already responses.none and we want to check it is it.COVID positive. So none of the responses should satisfy this condition and it will return true if none of them do that, otherwise it will return false. And you can guess it will return false because we have some COVID positive people here in the responses. So the output will be false. And similar to none, actually we have other functions as well. So if you want to check if any of them is COVID positive, you write any, right? And it will return true if any of the elements in this list satisfy this condition. You want to check if all of the responses contain COVID positive student, you write responses.all. You have this various variety of functions already provided to you to make your code much more concise and readable. Okay, we want to filter COVID positive students. Someone give the syntax. We already have done this. How can you filter COVID positive students from this list of responses? Give it a try. Okay, let me do that for you. We have these responses here and we want to filter it. So to filter it, we write dot filter. And the condition that we want to use for filtering is whether the person is responses.filter it dot is COVID positive. Yes, you are right. Just that you will have to use braces instead of this parenthesis. Everything else is correct. We have two form responses that satisfy the condition. We have Alex, who is COVID positive, and we have Cherry, who is COVID positive. And what if you want to get the names of those students who are Cherry positive? Sorry, who are COVID positive? So just we have this filter list. Just map this list to a new list containing the names of those students. Yes, map. So two people satisfied the condition. Okay, last thing. Print responses sorted by student names. So we want the responses should be sorted by their names. So earlier we had done that sorting a list by their absolute value. So here we want to sort the list by their name. So list, you can guess, sorted by, not list, responses dot sorted by dot name. It will sort them in the ascending order of their names. We will have, like, it will be the same order anyways, but even if the list was jumbled up, so it would have given this output. So Alex, Bob, Charlie. Okay, so it's 440. Let's speed up a little bit. Next. Okay, so you have been given a list. Let's take a use case. So your semester has started. You have been assigned projects. So your TA has asked you to form groups of 4, right? So among all the students, you need to form groups of 4, or let's say 3, in the increasing order of your roll number, right? So the first 3 students will form one group, the next 3 will form another, and the next 3 will form another. So like these 3, one group. So instead of those students, we have integers here to just simplify our use case, and the remaining ones will be in the last group. So how can we do that? So the C++ version or Java version would be something like creating a new list, then creating a temporary list for each group, then iterating on the entire list, and then adding elements to that new list. When the size of new list becomes 3, I want to empty that list and put all the elements in the original list. And at the end of the loop, I also want to check that if the list is non-empty, I have to like put it again. A lot of work to do, even if you did not understand the algorithm that we'll use to break it into small chunks. Let's not do all that. Let's see the Kotlin version. We have a list of students and we want to like break it into chunks. So for chunks, we have this function called chunk. We can just pass a size. So chunk size. We want to break it by size 3. What this will do is it will break this list into like a list of multiple lists, and each inner list will be of size 3, except the last one, which has less elements. Right, so the first group is of 3 elements, 1 2 3, then we have 4 5 6, and then the last list has 7 8. So it's kind of a nested list, a list inside another list. Like another common use case was like pagination, when you have multiple pages and you want, like you have a large amount of data and you want to paginate the results. So one page showing some data and the next page. Function is quite useful there as well. Okay, this the opposite of this chunk. Now you have a list of list. So like from the previous example, you can take it as a list of marks, like at the end of the semester. So now the teacher wants to like flatten out the entire list. So we have a list of marks, but we want the list of just individual students. So what we actually want is, we have a nested hierarchy here. We have like a list inside another list, and what we want is to flatten this out, this hierarchy. Please explain chunk again. Okay, we'll come back to it just after this. So what we want to do here is, we have a list of items, and we want is to flatten out. Okay, let's print it first list. What does this look like? Like before this, do you guys have any other session at 5 that you have to go to? Is there any other workshop remaining? Like which one? This club. Okay, so there are a lot of clubs with a lot of workshops here. So let's try to finish fast. So we have this nested list, and what we want is to get the final output as is just 1 2 3 4 5 6 7 8. Right, so what we want is to flatten out this entire list with nested hierarchy. So we call dot flatten, and let's see the output. As you can see, we have like just a single list of items. So 1 2 3 4 5 6 7 8. So we have like flattened out the entire hierarchy. And what would have been the C++ equivalent? You'd have to create a new list of integers. Then you would have to run a nested loop, one for the outer list and one for the inner list. and then you would have to add elements one by one. It is pretty compact. Okay, let's come back to this chunked as well again. So we have a list of items and we want to break it into smaller lists so that we can process those small lists. So for example, that groups example, suppose these are the roll numbers that we have and we want to make a group of first 3 students and then the next 3 and then the next remaining 2. So how would I have done this in C++? Let me just type it quick. So we would create a new table list, and this list would have been again a list of int, and then we would have a temp list for the inner list, and this would be like a mutable list of int, and we would have to iterate on the entire list, add that element to temp list. So temp list dot add I. Now we are adding to temp list. Now if the size of this temp list dot size becomes equal to 3, we want to add this smaller list into our original list. So new list dot add this smaller list, and then we'll have to reinitialize this to a new list so that we can get a fresh list. And after all this, it is possible that we have some elements remaining in the template at end. So what we can check is temp list dot is empty. Again, we want to add this one to the new list. So new list dot add temp list. If we print this new list, it will do exactly the same thing that chunked was doing for us. So like if you are not using chunked, you can still write this code in Kotlin, but then it would be a lot of boilerplate code. So you can avoid all this stuff by just calling a small. We missed something. Okay, if this is not empty, if template is not empty at the end, we want it to be added to the new list as well. Okay, now we have this output. So like 1, 2, 3, around 10, 12 lines. We can avoid these 12 lines of code with using just a simple Kotlin function, which is dot chunked. I hope it should be clear right now. Okay. Okay, let's talk about something else. Another use case that we have. So we have a data class called student with 2 properties, name and branch. And I have some sample data with me where I have names of some students and their branches. Now, our use case is we want to group these students by their branches. So that for each branch, I want a list of students which like kind of correspond to that branch. And this is a very common use case. So for example, you want to group a list by some data. Here we want to group the students by their branches. We have students here. And we want to group these students by their branch. If you want to group students by, we call group by. And group by what? Group by their branch. That's it. Like in other language, you have to create a map. And what it will return, it will actually return a map of string and student. So let's see the output. It's actually a map. You can see by this sign. This is the key that we have. We have the branch CSC, and it has this array of students. Like we have Arpit, Priya, and for ECE we have Rohit and Muskan, and for MNC we have Aditya. So you can just club these data, this list by just single line dot group by. Another use case. Let's say we want a map of a student name to branch. So for a given student, I want to know what branch does he belong to. So we want to associate student names to their branches. It dot name to it dot branch. That's it. Almost English, very close to English. Let's see the output that we get. No, not by. We want to associate name to branch. So we have for Arpit we have CSC, for Rohit we have EC. And if you check the type of this, so instead of printing it, just store it in a variable. You can see the type is map of string, comma string. So if you want to know the branch of, let's say, Arpit, it will give us map corresponding to this key. So in this case, it should be CSC. Map creator. Yeah, you can see it's like it converts lists to maps, like in a very concise way. So we have CSC output here. If you write something that's not present in the map, it will give null, as you have seen earlier also. So pretty convenient way to like group data, I should say. Okay, let's see some more powerful stuff. And this is like the second last or the last slide. Stick to with it. So extensions. So like you have seen a lot of functions that are already provided to you. So like for a string, I have a lot of functions like substring, dot take first, dot count characters, dot map it to different lists. What if we do not have something like, let's take a phone number, right? So something we want to check it contains only digits. I want to check if this string contains only digits. But you can see this function does not exist, that we do not have this function. So we cannot write it like this. In this case, what Kotlin allows you to do is you can extend the already provided classes and add new functions to them. And the way we do it is by something called as extension functions. So how do we create them? So we start with this from keyword. Now what we want is string dot function name. This is how we call it, and this is the same way we will define it. We'll write string dot, and this function contains only digits. Now we have to give the implementation. I will use is equal to syntax, and what we want is to check if all the numbers in, like all the characters in this string are digits or not. So if you want to check for all, we use this function called all. So this is all function is available on this string. And what we want to check if it, so it is a character here, you can see this char. We want to check if it is digit or not. So we have a character, we want to check if this is digit or not, we call dot is digit. As simple as that. And now this error goes away. If I run this program, and actually all the functions that you have seen till now, which are like filter, map, count, sort, all these are extension functions. Returns true. So like if I add a non-digit in it, I have added a dot here. So what will it give now? It should give false, right? Let's see. It will give false. So you can create your own functions on strings, and it will look like string. Now, just to give another very simple example, let's have a list. Let's create a mutable list of all have studied about sorting, right? So I have a list of very simple list of ints. And how do you swap two indices, right? Swapping is pretty trivial, right? We write something like this. We like what if we want to swap data at two indices, for example, like say this and this. What we do is we create a new variable, we store this value here, we put this value here, and then that temporary variable value here. Like 3 lines of code to swap it. What if you could just write list.swap, and let's say 0 and 2. So I want to swap these two indices, it's 0 and 2, and then like let's say print it. But again, swap function does not exist. Will this function be applicable to all files in the directory? Yes, it will be. Like if you want it to be available for only this, you can write private here. But if you want it to be available everywhere in the project, you can just skip it and it will be available everywhere. It's actually a very powerful thing because you will end up creating a lot of these functions so that you can improve your code. Because this looks much more readable than if you had done something else. Now list.swap. We don't have this by default, right? So what we can do is we can extend this mutable list of integers and add this function. We can add it at one place. For example, let's say a utility folder in your project, and you can use it anywhere in the project. How to do that? First, define the data type. So our data type is mutable list of integers, and we want to define a function called swap here, which takes two variables, is index 1. You need to write the same code, but that code is now at a different place and it's much different. So first thing, you can see that error is gone because we have this function on mutable list. Now how to write the code? Very straightforward. Like swapping two numbers, we get the value. And now how do we refer to this list? So whatever you have before this dot, the type, you can refer to this type using this keyword called this. So if you're familiar with Java, like this is the way to refer to the current object. So this index 1, so we get the item at index 1. We replace the item at index 1 with index 2. And then we replace the item at index 2 with the temp value. The standard code that we have, but now it's separate from the original code. Let's run it. And what do we expect here? Like this 1 and 3 should be swapped. So 3, 2, 1, 4. This is what we are expecting. Let's see if we get it. So yes, we get 3, 2, 1, 4. It's just another way of swapping it. Like in Python, you remember it was like way more simple. Like a comma b is equal to b comma a. We do not have that in Kotlin, but something similar that we have is something like this. So this dot index is equals to this dot index at 2. What you can do is you can use this also function. Do this and also do this at the same time. Right? So this is again, it will also work. Because at index 1 put this, also at index 2 put this. So this will also give the same output. This is again extension function, a very powerful feature of Kotlin. What else do we have? We have generics, right? Let's see what Kotlin offers functions. Now generic function, again a category of very powerful features of Kotlin. Let's create a list here. So list of 1, 2, 3, 1, 2. If you remember, we had used this function called count, right? So list dot. Okay, if I want to count how many numbers are equal to 1, can someone give me the code for that? Like among this list, how many numbers are equal to 1? What will be the code for that? List dot count, it is equals to 1. Yes, very simple. We don't have this function actually. Okay. I would like use braces because for lambda function we have braces. And another thing is that we want to check for equality, right? So for equality, we have, if you remember, we have this symbol, right? So this single is equal to is like for assignment. And for checking equality, we have this double is equal to function. Yes, you can also use this filter function and then dot count. But then again, that's 2 steps. We can do it in 1 step. So list dot count is equals to 1. But what I want is, we want something, I don't want to call this. I want a function like someone mentioned, like who did? Aditya. So I want to do something like this. I don't want to put in curly like quotes because it's not a string. I want a function that works something like this. Or if not like this, let's be more explicit. Something this. So list dot count equals 1. So I will give you a number and you need to tell me how many times it occurred in the list. List does not have a count equals function. So what's the way to go? We can create our own, right? So on this list of ints, we can create this count equals function. We'll take a number and instead of calling it a number, let's call it an element. It's an element in the list. And the only thing that we need to do is to invoke the already provided count function and just write this. Right? So internally we are using the same function, but now at the call site it looks pretty much obvious, like list.count equals 1. Let's run it, and the output should be like 2. Does that work? Okay, did everyone understand this part? And then we'll move ahead. Did you get this part? How did we add this extension function? Yes. Okay, great. Now let's see what's the problem with this. This is was list of integers, right? What if we create a new list of strings? Let's say we have some strings here, right? No, let's name it something. Arpit, whatever. And then let's repeat one more time. We have this list of strings, right? And now if we try to call this function, so strings dot count equals, and I want to count how many times Arpit occurred. This is not working. Can someone tell me why it's not working? Because of int, right? So the function that we defined was for list of integers. Need expected an element of integer. So it does not work for string. So one thing that we can do is we can just duplicate it, replace it with, so it works with string. We can create a new function which works for strings. What if we have an array of doubles? What if we have array of boolean, array of long? We cannot always repeat this function for all types. What if we have our own data class? No, for if you have a list of students, how can we do that? We cannot do that. So what's the alternative? So what we actually want is that we want this function to not actually depend upon int, because you can see with the implementation, this implementation is not specific to integers. We are just checking about equality. We don't have auto here, and auto used to just do the same thing, like it used to infer the type for you. So Kotlin does that without using auto, right? Because you don't have to specify the type here. So auto is not present in Kotlin. So what we want is that this function should be independent of the type. Like compiler should not bother about the type of list that I pass here. What I actually want is that for any list of type X, right, our function should work. So if I have a list of type X and then eventually the element value of also type X, this function should work. But we have an error here, right? Because Kotlin does not know what X is. Can we use any instead of int? You can use any, but the problem with any is that, okay, let's just first use any. Now both work, but the problem is that the data type of the list that it will return also be any, right? So if I you can gets int, I mean, like you could use any here, right? It was a bad example. What if we want to, let me think of another use case. Let's say you want to filter a list, or you want to get a list in return, right? So we want to filter elements. Let's not count, let's filter. Okay, it took a counter example. So I want a list which filters this list and gives me a list of elements all equal to this one, right? So we could use this filter here. Now the problem comes is with this filter function, the type that it returns is also list of any. Now I cannot use type inference here. So I knew the original list was of type int, and now the new list is of type any. So I cannot like apply functions which depend upon ints. Not this list. Now this function does not exist anymore. So we lost the type inference. So let's not use any. What element do we have? So let's come back to the X example. We want to keep the type, like the type that we supplied as like this parameter. Actually, it's called a receiver in Kotlin. The type that we supplied here, we want to keep that type exact, intact. So we want something to be like list of X, the element will be of type X, but Kotlin doesn't know what is X. So what we want is that this X is actually a generic type. It's not a fixed type, it's a generic type. And how do we tell Kotlin that it's a generic type? Just write this. In angle brackets, you specify what are all the different like values for generic type that we are going to hear. For example, we are using the name X, right? So what I'm using X as a generic type. You can just specify, and you can see that all the errors are gone. And also we have that type inference back. So Kotlin can determine that this list.filter equals function. If we give it a, if it like working with integers, we get back a list of this. If we pass it a list of strings, so if we pass string dot filter equals and earthquake, so we get back a list of string. So type system is working, and now this function is independent of the type, so it works for any type, and that was possible because of this generics. And just a last point, that in Kotlin we have this small convention that when we are writing this generics, we use the variable t. No hard and fast rule, just a convention that whenever you are working with these functions, to create these extensions, like use the variable t. And just to show you, like we have been using this filter function right now, right? Let's open. So what does this filter implementation? What is the implementation of this filter function? So if we try to look at the implementation, so you can see it's also a generic variable on type t, right? It's an extension on something called as iterable. We don't care what it is, and it returns a list of same type t. So these extension functions and these generics are used everywhere in Kotlin code. This was about generics, and let's look at the last topic for today's session. So let's start by simple stuff, right? Banana, whatever. What will the output of this thing? Let's start simple. Apple plus banana. What will be the output? Apple, right? So the what this does is it just concatenates the two strings. So this plus operator has this implementation of concatenating to it. What if I write minus here? It doesn't work because Kotlin doesn't. You can see the red line here. So Kotlin doesn't know what to do with minus sign. You know, this unresolved difference here. So it's trying to resolve it, but it's not getting anything. So a lot of these errors. What we can actually do it, we can, now before that, let's talk something else. How do operators work? For example, if I write 2 plus 3, we have this operator. So how do operators work? So internally, what operators do is that they call functions inside them. So what this plus sign do is it calls a function that's called plus. So 2 dot plus 3. It will work as well. And it's doing the exact same thing that we were doing with the plus sign. So all the finally they always call some functions. So the minus one calls dot minus. The multiply sign calls this function called dot times. So if you want to multiply 2 times 3, we have this function called times. We have divide. And for in like a plus plus, we have increment functions. So what we can do is we can define our own implementation for this sign. How do we do that? Normally we define a function like fun, and this will be an extension function. So list dot, and we need to define minus here, right? And we want this function to be an overloaded version of an operator. The only thing we need to do is add operator here. And then we can take another string and we can define our own implementation. So we can think of any implementation, right? For now, we can think that just remove all the letters from the first string that are present in second string, just like what we were doing with lists. So how to do that? Just filter and take only those characters which are not present in S. Right? So now you can see this error is gone. And if you run it now, the output will be, it will remove A because A is present in that, and the output will be like PPLE. So we can define our own overloads. Now, before ending this, let's come back to the pattern problem that we left here. We had let up this place. What we wanted is, we wanted to use that multiply sign with strings and integers, and Kotlin does not give that by default to us. What we can do is, we can create our own implementation of that multiply sign, asterisk, fun, and we want it to work with string. You can see there are a lot of operators here, so you can, so which one do you want to overload? It's this times operator, string dot times and int. And what this should do is just call the original function that we had, repeat it n times. Same function that we're calling here. Now with this, what we can do is, we can now actually use this multiply sign, and you can see we have no errors here. This is what Kotlin allows us to do, like a lot. It's very sensible language. You can extend it to the extent that you desire. Let's see the output. So it's the same output that we were getting before. So now we can use like the Python like syntax here for this thing as well. And actually this was all for the part. Now I had actually a small task for you guys. What we had. So we had a small assignment. Let me read it out for you. So your college recently floated a willingness form for students who are interested in coming back to campus. And the administration needs your help to process those responses and prepare a list of student batches in the order they should be called back. And using the Kotlin skills that you have gained so far, can you help your batchmates reach college faster? So we have this GitHub repository for you. What you need to do is, similar to all the previous assignments, just fork it. Like here also you can find all the code that we have done in this session. So all those files are here from generation, session, operator overloading. And inside we have this assignment folder, right? You can also access it from here in the README. So we have given you a text file containing the responses. So like there was a form floated, and these are the responses. So we have serial number, we have student name, his roll number, branch, and whether he's COVID positive or not. So we have been given this data in a text file. What we have to do is, we have to read the data in this text file. The instructions are also mentioned in the README. You have to read the list of student responses from this text file. The first thing that you need to do is, you need to filter out those students who are not COVID positive. Like obviously, right, you cannot bring back COVID positive students. The next step is sort those students according to their branch names. So the policy college is applying is that they are calling students branch wise, and those branches are like in increasing order of the, like ascending order of the names. What we want is that we want to sort those responses in the alphabetical order of their branch names, and within each branch you need to sort the students by their names. So this is the requirement that we have, and once you have sorted out the branches, you need to break branches into groups of 3. So the pattern that we are following is that breaking all the branches in groups of 3. So the first 3 branches will be called first, and then the next 3, and then the next 3. Now once you have formed those branches, those batches of students, you need to save the output in another text file, and it should look something like this. So from the original list, we had 25 students. We filter out the 5 students which were positive, and now we have this. So batch 1 brings chemical, civil, and computer science branch to the campus. So in chemical we had 2 students, Chloe and Jack. In civil we had Emily, and in CSE we had 3 students. So you can see the 3 students are sorted in their ascending order of the name. So J, L, and S. Then in the next batch we are bringing back electronics, electrical, and mathematics. Again, like in each branch we have students sorted out by their ascending order of their names. And similarly we have batch 3. So you need to generate these 3 batches you are given. And where do you have to do all this code? There is an assignment.kt file that we have provided to you, right? So if I open this in the IDE, this is the file that you have. The instructions are here. So you can do this without using data classes, but I encourage you to use this data class so that you get type safety, right? So in the main function, you have 3 steps. First step is to read the responses. Second is to create batches using your responses. And the third step is to write those batches in the text file. So step one is like open that file. You can just search on Stack Overflow for Google, like how to read data from a file in Kotlin. It's just a one-liner code. So you can search it. That's your assignment. You can read those responses and prepare a list of responses. This is what you have to return from this function. And those list of responses will be used here to create batches. And this function will return a list of response. What does this mean? This inner list of response is one batch. So as you have seen here, is batches. So this is the inner list that we have. So this is the list of, this represents one batch, and this list represents a list of batches. So you need to return it here, and then the last thing that you need to do is create a new file and write that data in that new file. So we have the batches input here, and we need to write in the new file. This is the response model. We have name, roll number, branch, and code positive, similar to the data that we had seen in the text file. Actually, it's a pretty simple assignment. Like if you're familiar with the operation that we had done, so like we are filtering, we are sorting. Can anyone tell what is this operation? That once we have a list of branches, we want to divide it into groups of 3 chunked. So actually, I taught you all these concepts that are going to be used in this assignment. And if you have paid attention, I think it would hardly take you like maybe an hour to figure out everything, to learn how to read data from a file and all that. It's not a very big assignment, a pretty simple one. So I would say give it a try, fork this repository, and let me share the link right in the chat, right? So how can I copy it? You can fork it right now. And also for the slides, I think I can share the link. Okay, I'll share the link of, can I share it? Okay, I'll share it at the end. Like we have one more slide to cover, and then I'll share the link. So you can check out the GitHub repository. You have the code there. Just fork it, clone it, and just complete all that you need to do. Last thing, some resources. If you want to learn more, now depending upon what mode you prefer to learn, if you like videos, the first we have a Kotlin tutorial. It's just a normal playlist in YouTube. You can search for more that you can use to learn more Kotlin. Then this is a session from Google I/O where the lead Kotlin, like the one who designed this Kotlin language, has given kind of a comparison between Java and Kotlin. It's actually a great talk. If you prefer reading books, you can check out this Atomic Kotlin book. I don't usually read books, but it's a good one. If you like reading docs, you can check out the official docs, or this another. If you go to that link, it's a pretty intuitive one, right? You can read it here and learn more about. So we have something about hello world. So some code here, then var, val, data types, functions, string templates. If you want to practice, these are 2 links. The first one is actually a cones. So Kotlin, what are Kotlin cones? So these are actually kind of online examples, right? So they give you some function and they give you what is the desired output. So for the first one, you need to make it return okay, right? So the only thing you need to do is just return okay from it. Run it, and it will check whether you've done right. So it passed it. If you want to revert, you can revert. If you want to see the answer, you can see the answer. So a lot of such small codes here. And if you want to practice, like we have all these functions like associate, group by. We have seen some of them, but there are a lot of more. You can try out this source for learning more. And have you guys heard about advent of code? Has anyone heard about this? And what is advent of code? Any? Okay, so actually advent of code is an yearly coding, what you can call it, an exercise maybe. It opens on December 1, and from December 1 to December 25, like every day they give you a one question to solve, right? And for that each question has two parts, and for each part you get a star. So it's something like competitive programming, not really. So they give you some problem, and then you need to solve that problem. You need to submit the answer, and if it's right, you will get a star. So a lot of people attempt this thing. You can also try. And if you get stuck, like I had solved it last December. So I have shared my solutions to the problems, the 25 problems. You can check out these ones, and you can find the code for that problem. So you can try it out. It's also again a good exercise. And the last one is, for more information, you can go to the site kotlinlang.org/education. In the bottom, you can find plenty of resources, like from getting started to basics, playground. And if you guys didn't know, we have a competition called Kotlin Heroes on Code Forces. So in Code Forces, it's not Code Force link. So like once in around 3-4 months, we have this contest called Kotlin Heroes, where you can only submit problems in Kotlin language. So if you want to do some competitive programming with Kotlin, you can also do that. And we'll share the slides. Okay, at least they'll be available in the YouTube video that we'll upload into Cops YouTube channel. And that was it for this session. Let me just share the slides with you. Like, the slides do not have a lot of content, but just the links to these resources. So that's it from our side. If someone wants to ask something, you can ask it right now. And doubt related to the Kotlin or assignment or anything. So I guess there are no doubts. Thank you all for attending. And this is where we stop.